Hey, all right. Today we are going to be solving trig equations using inverses. This is actually 14-2. Today's date, as always, is today, and our objective is to evaluate inverse trig functions and to solve equations. So we have done a lot where I give you an angle and I say find the sine or the cosine. And what's going to happen now is they're going to give you the sine, the cosine, or the tangent, and they're going to say, hey, find what the angle is. You will definitely want to have your unit circle out in front of you for this one. All right, for our first one, we want to find angle whose sine is radical 3 over 2. I'm actually going to, let's talk about positive and negative first. So if I had a coordinate plane system, we know ordered pairs here are positive, positive. Here my ordered pairs are negative, positive, negative, negative, and positive. Oops. Getting crazy with the mouse there. Negative. So if I did sine, cosine, tangent, here sine is positive, cosine is positive, sine over cosine is positive. Same thing here. If I did sine, cosine, tangent, my sine is positive, my cosine is negative, my tangent is going to be negative. Here, my sine is negative, my cosine is negative, but my tangent is going to be positive because a negative divided by a negative is going to be a positive. And when I talk about positive, that means my value is positive. And in my fourth quadrant, my sine is going to be negative, cosine is positive, tangent is negative. If you know those relationships, when you're finding your angles, it's actually going to be a lot easier because you're going to find that some of these are going to have more than one. So let's go back and do this first example. Put this on highlighter actually. So I want to find the angle whose sine is radical 3 over 2. Well, I know that that would be my y-coordinate. Well, my y-coordinate is radical 3 over 2 there, and right there. So the answer to this one is going to be at 60 degrees and at 120 degrees. For the next one, I want to find the tangent of negative radical 3 over 2. Well, automatically, I know I'm going to be either in quadrant 2 or 4. And sometimes on your unit circle, it helps if you have the radicals or the tangents marked off to the side by the ordered pairs. That way you don't have to figure it out every single time. I just know that 1/2 over radical 3 over 2 gives me 1 over radical 3, which when you rationalize it is radical 3 over 3. Now that needs to be negative, but that tells me my coordinates. Remember, tangent is y over x. I'm going to go back to my highlighter. That is going to be at right here and right there. So the angles there we'll write this one in red so it's not in the same color, is going to be at 150 degrees and at 330 degrees. Depending on how the problem is written, sometimes I might ask for those angles in radians. In that case, it would just be 11 pi over 6 and 5 pi over 6. All right, let's do another one. On this one, they want the cosine of negative radical 3 over 2. Well, I know cosine is my x-coordinate, so that is going to be in quadrants 2 and 3. Looks like right there and right there. So the answer there is going to be 150 degrees. Looks like I got crazy with my one there on the 150. And my other angle is 210 degrees. However, sometimes you're going to run into things that are not going to be perfect on the unit circle. So on this one, we want to use a calculator to find the radian measures of all angles having the given trigonomic functions, values. So what I'm going to actually do is bring up my calculator. Okay, so once I have the calculator up, and depending on the type of calculator you have, you might be doing this slightly different. Well, I want to find the angles whose sine is 0.6. So I'm just going to go ahead and put 0.6 in this one. And then usually you're going to have to do a second function. On this one it says inverse sine. And I get 36.86. However, when you are doing this, chances are you're going to have two answers. So if I were to sketch 36.86, it would be roughly there. Not 100% drawn to scale. Well, and that 0.6 is positive, so that means it's going to be sine is positive in the first quadrant and in the second quadrant. This is where you're going to have to use a little bit of your problem solving. So I need to get this angle right here, and that would be 38.6, but I don't want to give it like that. I actually want it in standard position from the positive x-axis to that angle. So that is actually going to be 180 minus 36.86. So let's use our calculator on that. 180. Oops, let's try that again. That's not good. 180 minus 36.86. And I get 143. So my other angle is 143.14. So if I wanted to verify that, and again, these are approximate because I did do some rounding, but if I wanted to verify that, I could clear that out and have 143.14, take the sine of that, and it's not exact, but it's pretty close to 0.6. One thing that you'll want to do is make sure your calculator is in the correct mode. I'm finding degree measurements. Sometimes you might need to find radian measurements. So let's go ahead and find the angles for 0.4. Well, that's cosine, so it is going to be there and in that. Remember, those are the two quadrants where your cosine is positive. So let's go ahead and use our calculator. Clear everything out. 0.4. We'll do the second cosine, and I get 66.42. So if I were to draw 66.42 in the first quadrant, that's what it would look like. And if I drew it in the second or in the fourth quadrant, it would look like that. However, I want to start from the positive x-axis and go around to that terminal angle. So what I'm actually going to do is go, well, if I went all the way back to that x-axis, that would be 360 degrees. So let's just take 360 minus 66.42. And I get 293.58. All right, let's get the tangent whose angles are negative 1.2. Well, if it's negative, it's going to be in quadrant 2 and in quadrant 4. So let's use our calculator. Inverse tangent, and I get negative 50 point, I'm going to just round this one to 2. Which would be right about there. Well, I want to write that as a positive angle. Remember, negative is you're going clockwise. So that is just going to be adding one rotation. So let's go ahead and add 360 to that. And I get 309. What was that? 309.8. All right, well, that's the one that would be in quadrant number 4. We want to find the angle that would be in quadrant number 2. Well, that right there is 50.2 degrees. We want to go from the positive x-axis to that terminal ray. So that's going to be 180 minus 50.2. And I'm going to get 129.8. All right. These can be really kind of tricky. You want to make sure you know which quadrants it's going to be positive and negative in. And don't try and do these in your head. Draw a diagram. Draw the angles in those quadrants. Then you're going to have to think back to your knowledge of geometry. And remember, one rotation is 360. A straight angle is 180 degrees. You're going to use that. All right, let's go on to our next example. All right, solve for the equation for theta. Looks like that might have a slight typo or something. We covered it up. So we want to solve in the range from 0 to 2 pi. Sometimes you might have to add or subtract more rotations. Let's go ahead and get this one. Just a second, though. All right. Well, in order to solve this, it needs to be set equal to 0. So I'm going to have 2. Well, let's do that in black. That's going to bother me. 2 sine theta cosine theta. And what I did was I subtracted cosine theta from both sides. Oh, guess what? We get a factor. That's everybody's favorite. Looks like the greatest common factor there is cosine theta. So I'm going to have cosine theta, parentheses, 2 sine theta minus 1 equals 0. Hey, we have two factors and it's set equal to 0. That means that each factor, if we set it equal to 0, we can solve. So cosine theta equals 0 and 2 sine theta minus 1 equals 0. Well, that one's pretty much already solved for. Here, I'm going to add 1, divide by 2, and I get sine theta equals 1/2. All right, let's find our answers. I'm going to write the answers in red because that sounds like it would be fun. Cosine theta, that means my x-coordinate has to be 0. Well, that happens right there and right there. On both of those, my x-coordinate is 0, so I'm going to have pi over 2. Imagine that's a better looking pi. 3 pi over 2. Oh, that's a horrible looking pi. All right, let's solve the other part of it, where sine theta equals 1/2. That means that is where my y-coordinate has to equal 1/2. Happens right there and right there. So that'll be pi. Okay, there's a good looking pi. There's a good looking pi, even though I didn't say it well. Pi over 6, and what's the other one? 5 pi over 6. All right, we need to make sure you would put all 5 answers down on an answer line. Let's do another one. This one's already set equal to 0. That's kind of nice. I bet you we can find a greatest common factor, sine theta. Factor that out. Not my best handwriting day. Sorry about that. I'm writing with a mouse. I'll try and make the next line look a little bit better. So you're going to take that sine. All right, I just said I was going to make that look better, and I made it look worse. Let's try that again. Sine theta equals 0 and 2 sine theta plus 1 equals 0. Well, that one's already solved for. I'm going to subtract 1, divide by 2. I'd get sine theta equals negative 1/2. Now both of these are sines, so I need to find out where my x-coordinate, or my y-coordinate, I'm sorry, is 0. Happens right there and right there. So at 0, 0 is the same thing as 2 pi. And at pi, this one actually has 3 answers right there. And when its sign is negative 1/2. Right there. And right there. That's going to be at 7 pi over 6 and 11 pi over 6. So it's all of those answers. All right, let's do one more. Actually, we're probably going to do 2 more. Here, start by subtracting 4 radical 3. When you do that, you get 5 tangent theta minus 5 radical 3. Well, your GCF there is 5. So 5 parentheses tangent theta minus radical 3 equals 0. That 5 really doesn't matter as a factor because there's no variable with it. So this is the factor that matters. So I'd have tan theta equals tan theta minus radical 3 equals 0. I'm going to kind of do that step in my head and have to say that tangent of theta equals radical 3. Remember, tangent is y over x, so it will happen at pi over 3 and at 4 pi over 3. Again, it really might be helpful if you were to take your unit circle and put your tangent values right by your parentheses. All right, one last example. Let's think back to probably Algebra 1. We can factor that. Think to yourself, how can I factor that? Maybe if I said difference of 2 squares, something would come to you. Cosine squared, perfect square. 1 perfect square. So that's really going to be cosine theta minus 1 and cosine theta plus 1 equals 0. So cosine theta would have to equal 1, and cosine theta would also have to equal negative 1. Well, that's your x-coordinates. Looks like it happens right there and right there. So 0, pi, and 2 pi. All right, I hope you had fun. See you for the next section.